Hey everybody, welcome to Astronomy 102 online. Today we're going to start with a clicker question reminding us what we talked about last time, the different types of galaxies. I'm just going to put this up here briefly. You should write down your answer. You can pause the video, and then at the end you will need to do the Moodle quiz for all the iClicker questions for today. This will be the first one in that quiz. You only get one attempt at that quiz, and it counts the same as clicker questions. So let's get started on our new material. Today we are going to be talking about dark matter. This comes from section 25.3. Dark matter, interesting topic. We are going to first start by talking about why we think there is dark matter. We don't know what it is. We'll get to that eventually, but we're going to start by saying why we think it's there. And it ties into what we've been learning about spiral galaxies. So the evidence for dark matter first came from something that we call spiral galaxy rotation curves. And I will try my best to write neatly. This is a new pen and a different type of system, but we're going to get it, okay? Spiral galaxy rotation curves. What we're talking about here, when I say rotation curve, is that we're looking at how fast are the stars orbiting around the center of the galaxy. So orbital speeds. So orbital speeds of what? Of stars. Okay, so we have orbital speeds of stars, and it turns out that those speeds, which tell us how fast the galaxy rotates, depend on a couple of things. They depend on the amount of stuff there is, the amount of mass inside of that orbit, so basically this is saying, where is the star in the spiral galaxy, in that rotating disk? Is it close to the center? Is it farther out? Are there a lot of stars inside of its orbit? A lot of stars between it and the center of the galaxy, or not? So the orbital speed of stars, how fast our sun goes around the Milky Way, depends on where we are in the Milky Way. Are we closer to the middle or further out? And just to be totally complete about that, depends on mass. So the amount of mass inside the orbit and the distance from that mass. Okay, so the idea is here, if we're out here in the Milky Way galaxy, we go around that galaxy, that's our orbit, and what's inside of that, and how far are we from it? Most of the mass of the galaxy is here in the center, in the bulge, so are we close to that? Are we far away from that? Are there a lot of stars? Are we most of the bulge inside of our orbit, or just part of the bulge inside of our orbit? Okay, so that's the idea there. So let me just write that down just sort of in those terms. Okay, so sort of a short version of what I just said is that if you have more mass, that means the star is going to go faster. You have a faster speed. But if you have more distance, you're farther away from that mass, maybe on the very edge of the galaxy, then you're going to go slower speed. Okay? So we'll break this down. You're going to get to do a lecture tutorial on this eventually. but let's just sort of talk about it with some examples here. So let's just start by saying some basic facts that'll help us understand what's going on. First, there is more mass in the bulge, like I was showing you earlier. There is more mass, and when I say mass, I primarily mean stars. There's more mass, more stars in the center of the galaxy. Okay, more mass in the center of the galaxy. That is this blue curve here that you see on your screen right here. Density has to do with mass. It says there's a lot in the middle and not so much further out. Okay. What does this mean? What this means is, the orbit, or as we're going to be starting to call it, the rotation, right? Rotation curves, the orbit speeds or rotation speeds should go down as you get farther away from that mass, right? They should decrease as you go out, right? So I'm going to scroll this down a little bit so we can look at some of these other pictures. So here, this blue curve, we said was the amount of density. Over here, this is the amount of light. You can see it's brighter in the center of the galaxy. There's more stars there. So we would predict that as we get farther away from that mass, from the inside of the galaxy, the speeds will go down. Because we just said that if you have more mass, it's faster speed, but more distance, slower speed. So as you get farther away from the mass, the speed should go down. That's what should happen. I'm going to emphasize that word should, right? They should decrease. However, that's not what we see. And this is why we think there's something else out there, something that we call dark matter. So here's the big but. But, okay, I told you what should happen. Here's what we actually see. When we go out and we look at a galaxy and we actually plot the speeds of those stars in an actual galaxy, these are spiral galaxy, but when we plot the speeds as you go out, so another way to say that is speeds versus radius. When you plot the speeds as you go out in a rotation curve, okay, a rotation curve is this actual plot of speeds versus distance. The but is the speeds do not decrease, as I said, okay? The speeds do not decrease as we predicted. Okay, we had a logical theory. It was based on science, right? Based on physics. Get farther away from the mass, you get slower down. But this is what actually happens. And here's a picture of a rotation curve. Here's the galaxy right here. And this is what we expected. Here's the expected curve. But look at this. This is what we actually see. Right out here, we see those speeds sort of flatten. Here they actually go up just a tiny bit, but they flatten out. They don't go down, they flatten. This picture here, you're probably curious why there's this funky picture down here. This picture is of me when I was college age. I worked in Washington, D.C. at the Carnegie Institute for a summer, and while I was there, I got to meet this lady. She has since passed away. Her name is Vera Rubin. Vera Rubin and her collaborator, Kent Ford, were the first to see this. This was a huge discovery. You can imagine scientists were skeptical, but galaxy after galaxy, they saw these flat rotation curves. And this lady, she didn't win the Nobel Prize, unfortunately. She didn't get quite as much credit as she deserved, but super nice lady. I got to talk to her for a few minutes. You know, my little astronomy hero moment there. Okay. So let's sort of finish out these ideas before we have a break for a video and a quiz. Back to black here. So what does this mean? We see these curves that don't go down like we expect. This means that the stars, that luminous things that shine, that have luminosity, luminous, normal, star matter, and gas. This means luminous, normal matter. Oh, I skipped E, didn't I? Okay. I'll come back to E. I'll put it as the next one. Sorry, this is E. Luminous, normal matter cannot produce all the gravity in the galaxy. Okay, maybe that seems like a bit of a jump, but what we're saying is because this measured rotation curve is flat, there's something else out there, right? Remember, go all the way back to our first point. Our first point was that if you have more mass, you can get a faster speed. Mass and gravity are linked, right? More mass, more gravity. You need mass to get that speed. So the point that I skipped here was, and sorry, that's slightly out of order here, is the rotation curve doesn't decrease, is flat, more or less flat. So that means there is more mass further out. So rotation curve is flat means more mass farther out. Okay? And then the last point is trying to put all this together. So more mass, more gravity, flat rotation curve. There's something that we cannot see. Dark matter. Right? There must be something we can't see because it doesn't make light. So we can't see it, doesn't emit light. Sorry, my eyes are coming out funky. There must be something we can't see that doesn't emit light, that has mass, so is a source of gravity. And what is that thing? We don't know. We're going to talk about some possibilities. That is dark matter. Okay. Bottom line, dark matter. So now I'm about to end this video. Before I do, I'll show you the next clicker question. Okay, this will be the next one that you'll need to answer on that Moodle clicker quiz. And then I want you to go and watch the next video, the Minute Physics video called What is Dark Matter? It's just a short 1 minute that'll give you an idea of what we're talking about with this gravity business before we come back to the notes.